Again to the course. So in the last class we have seen how to do the timing modeling, quick timing modeling of a black box. That means how you can set the timing information, the resistance value, rise time, fall time, setup time, hold time, and then the physical informations about that black box you can set. Then you can save that library, and again you can reuse those library in your further design. Okay. So after that, actually you can just using that read underscore verilog or read underscore vhdl, you can read any verilog file, hdl file into the synopsis environment. So after doing this, reading your hdl format or hdl files in the design compiler environment, so after that what you can do, you can this run, analyze and elaborate comments. Okay. So after reading the hdl source files, what you can do, you can run this analyze and elaborate comment. So by writing this analyze minus format, the format is verilog with the library name of work with the corresponding verilog files is risk types.v. So here in this command you see analyze is the, that means command I am giving, so that you analyze. The format is in the verilog. If the that means format is vhdl, so at that time you have to write this as minus format vhdl. The library name, here I mentioned that as library name work. So if you mention another name, so here you have to mention minus library minus something, then the corresponding verilog file or vhdl file, whichever you are basically analyzing. So if you have, suppose you are analyzing multiple copies of verilog file in your design compiler DCM environment. So at that time how you can do that? So here at that time, here in the previous command you see only one verilog file I have read or I have analyzed one time. So now I want to analyze multiple verilog files simultaneously. So how I can do that? So within this parenthesis, if you just named all the verilog files, so all these verilog files will be analyzed simultaneously one by one. Then after that, so after analyzing, what I have to do, I have to elaborate. Okay. So the command for that, for elaborating, the command is that elaborate risk underscore core. That means this is the module name which I am now trying to elaborate, and this architecture is structural with the library name of work. Minus update means whatever, if I have done or I have analyzed or I have elaborated this file earlier, so minus update will update all those information and it will give you the current results. Okay. So after doing that, you also can, that means these things I think or I have already discussed that how I can read. So vhdl will be read underscore vhdl will read vhdl file, read underscore ddc will read the database file, read underscore db will read the .db file. So read underscore verilog will read .v file. Okay. So this is the command which you can run in DC environment. So now the next thing is that how I can change a design reference. So change reference design means that means suppose I have two cells U1 and U2 which are linked to the current design myadder. Okay. So for changing the design reference, how you can do that? The first thing is that you have to copy the design. Okay. So copy the design means you have to make a copy of that particular adder, that means here the name is that myadder, to another adder. So here copy design with the name of adder to the myadder. Okay. Then change link U1 and U2 to myadder. The following comments changes the link for cell U1 which is a lower level in the hierarchy, that is change underscore link with the corresponding path name of top / sub underscore inst / U1 with the corresponding library of LSI 10K slash AN3. Okay. So, that means what does it means that now I am basically changing the references of these things with this comment change underscore link. Then again another example, this you see that the next example is how you can use all instances option for changing the link for an inverter 1 when its parent design BOT is instantiated multiple times. Okay. The design BOT is instantiated twice in MID1 slash BOT1 and MID1 slash BOT2. So, at that time how you can do, that means in the earlier comment here you see only this top slash sub underscore inst slash u1 I am changing the link, but here change underscore link minus all instances indicates that means this BOT1 block wherever it is used, it will change the corresponding instance of INV1 everywhere. Okay. After so there are several other example of that, and you just see the last example, that is that this particular change link command, what it will do, it will links the U1 cell in the current design to AN21 cell references and maps the old pin names A1, A2 and Z to new pin names A, B, Y. That means now what it will do, suppose in the earlier reference name the name of the pin was like A1, A2 and Z. Now I want to change the pin name to A, B, Y. So how I can do that? So you can just do by typing this command change underscore link with the cell name of U1 AN21. Okay. That means AN21 is the current design name where this U1 cell is used. So the pin name from A1A, A2A, A2 to B, Z to Y. That means A1 to A it will change, A2 to B it will change, Z to Y it will change. Where it will change? This cell U1, that name will be changed in AN21. Okay. So after that, how you can design, that means create a design using this create underscore design with the your design name, and if you want to, that means what are there in the corresponding design, so list underscore design that it will show. Okay. So copy the design, I have already said. So how you can copy one particular design, copy design, that means what will be the name of the copied design along with which design you want to copy. Okay. So the next is the how you can rename a design. That means rename a design means all these things are that what you can do, you can just go back to the Verilog file and you can rename. But here in the design compiler itself, whenever you have already read the design, at that time you also can do. You don't go back to the Verilog file and you change the name and then again read all these libraries, Verilog files, then again you have to do. You just you have already read it, that the thing is already there in the memory. Now you can change, or you have the option to change the names, the port names, or copy the design. Everything you can do in the DC environment itself. So whenever it is already loaded in the memory, you don't have to redo the things again. So how you can rename the design, that means this rename underscore design with test new with test underscore new underscore 1. That means the rename design test new was the that means new name, the earlier name with the new name of test underscore new underscore 1. Okay. So that will be changed. So so there are several other examples like for a renaming. So I am not going each and every one of this. So the next thing is that how you can change the design hierarchy. Okay. So design hierarchy means we know that okay, design basically there is two hierarchy, top down or bottom up approach, okay, for design. So how you can change the design hierarchy in the DCA environment. So for that, and everything actually you have to write the corresponding command prompt. So in the command prompt, so here you see adding labels of hierarchy. That means now suppose there are two labels in one particular, suppose in I have designed one adder, okay. So there are three levels. Now I want to put another extra levels of that. So how I can do that? So to do that, to group two cells into a new design named samples with the instance name u, you just enter this command, group u1 u2 with the design name sample with and along with the cell name of u. Okay. So here u two cells means this u1 u2 is the two cells, the new design sample name, that means name is sample with the instance name of u, the cell name is u. To group all cells that begin with the ALU into a new design mu p with the cell name of u cell, how you can do that? Group ALU star. So ALU star means all the cells which is related to ALU. So that will be now grouped with the design name, in the design name my mu p with the cell name of u cell. Okay. So that means whenever I have only 2 or let us consider 4, so at that time within parenthesis if you mention, it is okay, you can mention. Suppose in ALU there might be 100 number of cells it has been used. So at that time mention every that means each one, that is quite tough. So at that time what you can do, within this colon you just press ALU star. So it will indicate or it will group all the cells which is connected or comes under this ALU. So all the cells will be grouped together in the design name of microprocessor. Okay. So that thing you can do it very easily in the DC compiler environment. So again there are several other examples like how you can group all cells in the HDL function bar. So with this FETG process with the name of new underscore block design. So how you can do that? So these are another example of in the HDL function itself you can change the design hierarchy. In the, that means cells wise you can change the design hierarchy. So these are the commands. So everywhere you see group, create the group to make the hierarchy or you to change the hierarchy. So after, so now that means I have already set. So what I said that okay, you have add, so at that time you put this comment. Now I want to remove a hierarchy. So at that time how I can remove? So there I put a group. So here the command is ungroup. That means there if you are putting clubbing two blocks, two cells together. So here I will just that means ungroup that particular cells to reduce the or to remove the levels in the hierarchy. So here you see there are several example or several commands like ungroup this for these particular cells. So ungroup u1 with prefix u1. So u1 cell will be ungrouped. So ungrouped all flattened, that means all the hierarchy will be collapsed. So as we have seen that in that hierarchy design we have seen in the that means last lecture we have seen. So that thing can be done in by using in, that means you can use this ungroup command for removing or to resolve the levels of hierarchy in your design if it is required. So ungrouping hierarchies explicitly during optimization. So optimization means basically we are if there is more number of levels, so obviously the delay will be more. Okay. So if you during optimization, logical optimization or area optimization or any other optimization, what we are trying to do, we are basically reducing the levels so that the path delay becomes shorter or the critical path becomes shorter, okay, to enhance the performance of my design. So whenever we are doing this, and what I said, we can, that means remove the levels in hierarchy by ungrouping it. So specifically you can do that by putting this command, that set ungroup U1. So it will do what? It will ungroup cell U1 during optimization. Then you put compile ultra, so it will do the optimization with ungrouping this U1 cell everywhere in the design. So to see whether an object has ungroup with this attribute set, that get underscore attribute comment object ungroup. So there are that means this you can do using this command, ungroup set underscore ungroup with the cell name. So then as I said that, okay, how I can translate the design from one technology to another. Translate one technology to another means, so initially what I said that whenever we are that means reading a design into the design compiler environment, so before that I have to read the Verilog file as well as I have to read the technology file. So once I have read it and then compile it, so it becomes technology dependent. So technology dependence means which technology file I have provided, information I have provided to the DC compiler, DC environment, so it will be mapped to that particular library. Now suppose that particular library I want to change now. So how I can do? One thing you can do, you start from the scratch, that means again you put the new technology file library name there, you then again read the Verilog file, so everything you can do starting from the scratch. So instead of doing that, that means the design is already, that now it has already been done, that means it has already read into the synopsis memory. So on that particular timing instant, so now how can you change the technology library information? So to do that, what you have to do, first you have to read the file in dot, that means in the data mesh format, which is .ddc format or .db format, then set target library as the new logic library, okay. Then put this command translate, so automatically this will translate the design in a design compiler topographical mode. So that means topographical mode means actually this you have to once you have, that means you have just load that corresponding new library into the design DC compiler environment, and then you put your translate this. So the whole design now it will be mapped to the new technology library file, okay. So after that you in the topographical mode, how you can do that? So append the link library with the original logic library, then that means read your Verilog file, and then you run this compile underscore ultra in the incremental compile mode. So this actually you can do. The first thing, the first example is basically only the DC export mode or the design DC mode, but the second thing is that design compiler topographical mode. Actually topographical mode is little bit different. So there you can do the floor planning optimization, that means all these things you can do which you cannot do in the basic DC mode. So that's why in topographical mode it's something different. You have to do, or you have to follow several, that means different steps than the general DC mode. So after that, how you can define the design environment? Design environment means operating condition. You that means I have to set. So how you can set the operating condition? By putting this command like set underscore operating underscore conditions with wccom minus library
this library name is my_lib, and WCCOM indicates this is the worst case condition. So BC COM indicates that okay, this is best case condition. Okay, so the best case condition means, so whenever we will see the corresponding library, so at that time see the demo, at that time I will discuss about that, what is WC COM, what is BC COM, so everything I will show at that time. So after that, okay, defining. So here you see that how actually defining the drive characteristic for input ports. Okay, so drive characteristic means port characteristic for input port means, okay, so there are the input ports and output ports are basically connected with the input and output pads, right? So what is the drive, what will be the driving capabilities, what will be its fan out for each of these ports? Okay, so that you can define. So how you can define? So you can define that, okay, by setting this command set_drive. So set_drive 1.5 to I1 and I2 indicates that okay, the two ports I1 and I2 that will be are not driven by library cell, use set_drive command to define the drive resistance. So beyond 1.5 they will not be capable to drive. Okay, so there are several other commands like this set_driving_cell with this cell name of AN2 with the pin name of Z from pin B I4. So there are several examples for setting the driving path, that means constant for each of these cells that you can set in the design compiler environment. So again, how you can set the loads for input and output port? So you can set the load with this okay, maximum load for out 1 pin, that will be 30. You can set it this value 30, that you can set it by your choice, but with this command that set_load with then the value with the name of the port, that you can do. So then again you can say that okay, what will be the maximum load for fan out? So by this command set_fan_out_load, the maximum fan out is 4 for this port out 1. Then the corresponding logic value, whether that will be 0 or 1, so that also you can set with this set_logic_dc A and B, so which will set the values to 1, logic 1. Then you also can specify the output ports to be unconnected to any logic with this command set_unconnected_out. So out port that will be unconnected, that means that will not connect with any logic. So after that, how to, that means so in that means how to load the well-load models in the DC environment using this command, that set_where_load_model by this name 10x10. So if the name is different like 100x100 or 100x50 or any other name is there, so we have to put this name within this parenthesis, but the well-load model will be loaded into the DC environment only by this command set_where_load_model. Okay. Then so till now we have set all this environment, we have done this area optimization, or that means level of hierarchy reduction means we are basically reducing the that means we are reducing the critical path, or we are enhancing the corresponding timing information of it. Now next comes to this power optimization. So leakage power or dynamic power optimization, how you can do? So in the DC expert mode you can set that okay, set leakage_optimization true. So that means at the time what it will do, automatically it will, whenever you are trying to calculate the power, so at that time it will try to optimize with respect of power. So, till now during the synthesis process it has that means it has different methodology which is programmed itself into the DC environment, so that whenever the specification is not meeting in terms of timing or in terms of area, so at that time it can automatically incorporate those things to get the corresponding specification, achieve the corresponding specification. So, in terms of power, whenever we are trying to achieve within the specification, it will be within the specification. So, at that time I have to set this point that okay, set underscore leakage underscore optimization, that will be true. So, by default it is that means if you are not mentioning, at that time it will not optimize in terms of leakage power. So, the same things you can do, that set dynamic underscore optimization true. So, it will that means the dynamic power savings mode will be on. So, if it is false, that means it is off, if it is true, that means it is on. Then setting, how you can set the multi-threshold voltage constant. So, multi-threshold voltage constant, if you want to see, so at that time you have to put this command set underscore multi underscore voltage underscore constant with the group name of LVT and SVT with the percentage values along with the corresponding which cell you want to set the multi-threshold voltage constant with the name of that. Okay. So, that all these things you can do in the topographical mode. Then this topographical mode means in the earlier stage we are finding out the corresponding information what we can find out in the IC compiler mode. Okay. So, this how you can compare the design compiler topographical and IC compiler environment, how you can basically in the last class we have already said that okay. So, for initial design exploration, if we found that okay, the results are within 10%, that means this DC compiler topographical is within 10% of IC compiler results. So, at that time that is tolerable, or we can go further. If it is that means it is crossing beyond 10%. So, at that time that means the mismatch is beyond 10%. So, at that time we will not accept that results. So, how you can compare that two part in the initial phase, how you can compare that. So, at that time in the topographical mode you have to write this command write underscore environment minus consistency with the output name of dct.env. Okay. And using this write environment in IC compiler mode with write underscore environment minus consistency minus output with the name of icc.env. Now, how can you compare this? That means the two environment, this is DCT means the DC compiler topographical mode environment is this one, and ICC is the IC compiler mode environment is this one. Now, I will check this consistency checker with the file name of dct.env with the file name 2 with ICC.env, and along with that the log file will be saved in the corresponding temp folder, or this HTML that means in HTML format also the report will be saved as HTML underscore report. Okay. So, that means now design exploration can be done in this way. So, for today this is it. So, we will go further on this topic in the next lecture. Thank you.